Yes. Hold on.
Yeah, but you're lying, you can't.
Okay, recording is going. Let's make a graph. I'm so excited about this. You know what I'm going to do for this particular one is I'm going to zoom in a little bit. I learned from having done this one earlier that it will be beneficial for us to be able to see a little bit better on the graph paper. So
Yeah.
The first one about the.
Yeah, I did the compression.
yeah, this is the first problem on the backside, and we're calling it the backside because it's the side that doesn't say the name of the assignment. So we can safely just decide that that's the backside. You and I did? Hey.
Yeah, an element.
Like in.
So the function that we're going to graph is y equals negative 1/2 times the meat and potatoes part of the function is the exponential parent function 2 to the x, and then simple shift at the end of up 4. So as always, step one is going to be, let's get at least a handful of points on the parent function so that we have some points to move around, because that's really where it happens as we start moving things around. So if we just graph y equals 2 to the x, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4. And I got to be honest, I mean, we could do a few more, but honestly, where did that little guy come from? We don't need a ton. So maybe I'll do like one more. I'll do like 2. If I do 3, 2 to the 3rd is 8. So if I go 1, 2, 3, I go up 1, 2, 3, 4, 1, 2, 3, 4, and there's our point there. So this is just a graph of y equals 2 to the x, and we should also probably have a couple on the plane coming in for a landing side like those, and that should be more than enough. Okay, so there's y equals 2 to the x, and now we have to take into account all of our modifications. So what are they? Depends on your perspective. Think of it like this. Think of it as your y coordinates are going to be half as big as they used to be. So where it gets confusing is that with a vertical compression, a number less than 1 literally means to squish. Whereas with a horizontal, if I had that 1/2 up attached to the x, then a half would actually mean to get twice, right? So it's really backwards, but vertical means what you think it means. Half is half as high as it used to be. I'm just going to correct one thing you said. Make sure you do your stretches and compressions first before you flip. So the order should always go horizontal shift first, stretches compression second, flippy flips third, and then vertical movement fourth. That's a math term, flippy flips. Yep. If it's not, it is as of today, like if it wasn't before. So I'm going to take all my y coordinates and I'm going to squish them all down, squishing them times 2 or multiplying, however you want to say that. They're all going to be half as high as they used to be. So like this guy is going to be half as high, this guy's going to be half as high, this guy's going to be half as high, and the top guy's going to be half as high. So far, so good. And I could do more, but I'm getting into a zone here where you almost wouldn't be able to see the points, but their y coordinates are all half of what they used to be. So we can check the vertical compression off our to-do list. The next thing we're going to do is we're going to take all those purple points and we're going to reflect them vertically. And that means quite literally that they're going to move in a vertical direction. So don't mistake vertical for like a vertical mirror. The vertical reflection means that the points are going to flip vertically downwards. And so this purple point is going to flip down to here. This purple point is going to flip down to here. This one's going to flip down to here. And then Mr. 4 guy is going to flip down to right there. And we can start to see the graph sort of reconstructing itself. I mean, we can more than kind of see it. Like it's pretty obvious where the graph is. The last thing we have to do is move all the points up 4. And so it's just a matter of literally grabbing each one of those, like with a pair of tweezers, and you pick it up and you just move it up 4. I mean, so you just got to kind of keep track of where things are relatively. So like this point right here where I'm kind of, I don't know if you can see, can you ever see that when I'm wiggling my pen? You can see that? That point is a tweener, but I keep in mind that relatively it's close to the ceiling, right? So I'm gonna, oops. So I'm gonna stay close to the ceiling. And I'm gonna go up 1, 2, 3. And there I am, still close to the ceiling, but 4 units higher than I used to be. You just do that for every point now. So this one's a halfway. So I go up 1, 2, 3, 4. He's still halfway. This one's on a lattice, thank God. So we just go up 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then if you really wanted to add more points, you could continue to add them as the plane gets closer to landing up there. But really, we've got the pretty good structure at this point in time. How did that go for you there, Anna? The key to these, I just can't stress this enough. The key to these is to be patient and just, you got to know what order to do the transformations in, but then you just have to patiently implement them one at a time. As you get better, I found myself, because I haven't done graphs like this in like 7 or 8 years. As I started to get the vibe of the flow again, I found myself doing multiple transformations at once. So like I could grab a point in my mind and kind of maybe with the tip of my pencil and say, okay, I'm going to flip you this way, and then I'm going to move you up 3, or I'm going to cut you in half, flip you sideways and move you down. Like you can actually start to do multiple things at once if you want to. Did that make sense? You sure?
Yeah, that makes sense. Write it on my own graph.
You wanted to go over another one as well, I thought. Is it is it another, yeah, it's another exponential. Yeah, exponentials are pretty wicked, huh? Not, 14?
Yeah.
Oof. I don't know that I do. Give me a moment and I'll see if I can track one down. I think it's computer generated, so no, I modified it. I'm gonna have to look at it in a bit. Are you done with your graphs? Just hold tight. Okay. I was gonna let the computer make the key, but then I remembered that I added some little things to it, so that what the computer says won't agree with me. So as always, I need an x-axis and a y-axis. And we're just, again, going to graph the parent function. That's just how we should always begin this process. So we're going to start by just graphing y equals 1/2 to the power of x. And so this is an exponential landing. This is a decay problem. So rather than, like, from your point of view, coming up and then taking off this way, it's going to come in and land this way, right? So the fundamental points are, again, if you put in 0, you get 1. If you put in 1, you get a half. If you put in 2, you get a fourth, and so on and so forth. And then if we go to negative, then the fraction flips over and we start actually getting bigger. So like 1/2 to the -1 is 2. 1/2 to the -2 is 4. And then 1/2 to the -3 is 8. Are you okay with that? Okay. I realized, being a little rusty on teaching this subject, that I probably could have given another day to the parent functions, because if those aren't good, then everything else is kind of bad, right? So you got to be good on the parents. So there he is. And now we're going to add in our modifications, how many modifications do you see? Ooh, I've never done this problem before. I'm excited. How many do you see? Yep. I see 4. There's a shift to the left 2. There's a vertical stretch of ×4. There's a flip sideways across the y-axis, and then there's a movement of all points down 3. Now we just have to know what order to do all of this in. So what order, which one would we attack first? You know that cheat sheet I gave you that had all the colors on it? Honestly, once you get good at this, most of it you can ignore, because it's really just to get you started. But the bottom is your friend. On the bottom, there's like the order of operations to do things in. So we would start by the +2, that cute little +2 that's up next to the x means we should move all of our points to the left 2. Are you okay? So all of my dots, and we're going to go real slow on this one. I'm going to move all my dots to the left 2. So that one went left 2, left 2, left 2, left 2, left 2, left 2. And I am now going to kill off all of the points from before. So we good so far? Okay, the next thing we have to do is any stretches or compressions. And there is a stretch. And why do we know it's a vertical stretch on this one? Nice answer. Good. So since it's a 4 and it's in front, it's actually going to take all my y values and it's going to multiply them by 4. I'm starting to question whether or not I thought this problem through or not. So this might get interesting with our limited graph space. So anyhow, there's a couple that are going to be a bit unmanageable, but like I think all these ones kind of down here where I'm moving my pen are reasonable. So next thing we do is we take all the yellow dots and we multiply all their y coordinates by 4. So one that used to be up 2 is now up 2, 4, 6, 8. One that used to be up 1 is now up 1, 2, 3, 4. One that used to be up a half, 4 times a half is of course 2. And one that used to be up a quarter times 4 is now up 1. Did I lose you? You're still good? And like the next ones, as we came in for a landing, you can just see now that the graph is going to just work its way. It's come to the point now where it's time to start approaching the runway that it can never get to. After that, what's next? Yes, reflections come next. So, and there is a sideways reflection, and we know it's a sideways reflection because it's on the argument, the x. So all of my green dots are about to get mirrored sideways across the y-axis. Remember, a horizontal means the traveling of the points is in a horizontal direction. So all of the green dots are going to reflect to the dead opposite side, equidistant from the y-axis. So the distances stay the same. And the only point that doesn't feel the reflection is this one down here, because if you're on the mirror, you can't reflect. And then the plane coming in for a landing is going to come in now from the other side. Yeah, so like so this one, what was this one? This one would have been not a quarter. This one would have been an eighth, and an eighth times 4 is a half. So now we're down to a half, and then so on and so forth like this. And so the landing is happening right there. Are you still okay? You see how it's just a slow process, right? And if you just attack it one at a time, it's not that bad. The last thing we have to do is the -3 at the end. And that's just to physically pick up all the purple dots and drop them down 3 straight units. So each one, I'll make them red. If I just go down 3, I go 1, 2, 3, pop, 1, 2, 3, pop, 1, 2, 3, pop, so on and so forth. It's kind of usually the most, like, I don't know, maybe satisfying, because you kind of feel like you're putting on that last little sweet touch of paint when you're finishing a room, you know? And then the hard part begins, and that is actually trying to sketch this stupid thing and make your curves look good. So, yeah. JB, you need some help? Okay. Anyone else having any issues with the graphs? Does anyone need me right now for anything? Okay, can I look at your assignment 14?